Hello, hello everyone. Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. We already solved 6 problems in dynamic programming study plan. Let's solve the seventh problem, which is unique paths. The problem statement states there is a robot on MN grid. The robot is initially located at the top left corner, that is grid 0, 0. The robot tries to move to the bottom right corner, okay, which is grid of m minus 1 and n minus 1. The robot can move either down direction or right at any given point of time. Given two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. Test cases are generated so that the answer will always be less than or equal to this particular value. Okay, so if you see, we have been given a robot. It can take right or it can go down. Okay, so let's say if I chosen to go down, again there are two options for it. Either it can go right or it can go left. Okay, let's say if went to right, again it has two options, right or down. Now he has only one option because there is no grid on the down. He can only go right. Now he has finished. So this entire path is a valid unique path. Okay, this is one path. Okay, there will be so many such paths. He can also reach in this path, he can reach in this path, he can reach in this path. So there are so many possible paths, right? The idea is to calculate all those unique paths. Okay, let's say I'm standing at an index I comma j. Okay, so let's assume that we have a function which will always tell me the unique paths to reach m minus 1 and n minus 1 from given I and j. Okay, now we have to define this function. Okay, how we will be defining it? So since I'm standing at I and j point, I have two options, either to go down or to go right. If I choose to go down, that means my I, let's say my I is increasing in this direction and j is increasing in this direction. So my I will increase. So answer, so I need to identify the total number of ways in which I can reach from I plus 1 comma j to the end. Okay, so that is what I've written. Okay, if I take down path, that means I need to count the total number of ways I can reach from I plus 1 till j. If I go to the right, that means my j will increase, right? So I need to identify the number of paths from I and j plus 1 till all the way till the end. Okay, my overall answer will be summation of these two, because I can take this path or this path. Whenever there is or, we will be summing up the solutions. Okay, by now you might have already noticed this pattern. Okay, so the answer which is coming from the down and answer which is coming from the right, we will be summing it up. Okay, so this is the recurrence relation. Now what are the base cases we have? Okay, the moment I have reached m minus 1 and n minus 1, that means I have successfully traveled a path, right? That means it is one valid unique path, right? So I will be returning 1 once I reach m minus 1 and n minus 1. If I was reaching out of bounds either in m or in n, that means there is no way I can reach to again m minus 1 and n minus 1. So I will be returning 0 in this particular case. So these are the base cases which we have, and this is the recurrence relation we have. Okay, if you cleanly observe, there will be some position, some states which will be overlapping. Okay, if you see, in order to reach from here to end, I need answer for this, right? In order to reach from here till end, I also require answer for this. So this problem and this problem both are depending on this problem, right? So this is a overlapping sub problem for these two problems. Okay, so whenever we have overlapping sub problems, we need to implement dynamic programming, right? So let's go and implement the dynamic programming. Okay, I will be implementing it in the bottom up fashion. Using this recurrence relation, you can straight away implement the top down approach and do the memoization. Okay, let me show you. So I just had the same piece of thing here for my reference. Okay, so as I know, this is m by n grid, so I will go all the way from 0 to m, and j is going all the way from 0 to n. So the total number of unique unique states I have is basically m times n. So I have defined a dp array of size m times n. Okay, now Okay, if you observe in the recurrence relation, we are in the end reaching to our base case, which is m minus 1 and n minus 1, right? So answer to this is first found, and then answer to its uh, neighbors are getting found, right? So we will be also filling our DP array in the same fashion. We will be filling all the neighbors, and then we will be going up, okay, and we will be reaching to a start. Okay, so my for loop will be starting from m minus 1 and going all the way up to the 0, okay, and my j will be starting from n minus 1 and going all the way up to the 0. Okay, now if I'm standing at my finish line, that means it's a valid path, right? So I will be having one over here. Okay, and if you see all these, if I'm standing in the last row, there will be always one path. I can only reach in this path, right? So for all these coordinates, my answer will be 1. And if I standing in this particular column, there is only one path for me, right? So for these two cases, I will be having the state as 1. For rest all of the states, I can go down or I can go right. So that is what I'm doing. I'm going down, then my I is increasing by 1 and j remains same. If I going right, then my I will remain same and j will be increasing by 1. So my overall answer for given I comma j state is basically summation of these two. In the end, my answer will lie in dp of 0 comma 0. So let's try to submit this. You will be seeing the answer is pretty efficient solution. Okay, and let's also try to analyze the time complexity and the space complexity of this problem. Okay, so if you see, the overall space complexity is basically we are using a 2D array of size m by n. Okay, so the space complexity is basically mn, and we are also trying to fill these 2D array. We are not doing any extra work, right? And we have two for loops in order to fill this particular DP array. So this for loops, two for loops will take order of m into n, and that is the time complexity, and the space complexity is also the same. Okay, that's all about this problem. If you like the explanation, hit the like button, hit the subscribe button, and don't miss to share your valuable feedback in the comment section. Thank you.